Hi, welcome all to my YouTube channel. So this is dynamic programming part 2 tutorial. So in part 1 we discussed about what is dynamic programming and the approaches to dynamic programming, what is memoization and how tabulation works in dynamic programming. So in this tutorial we are more towards the practical thing related to dynamic programming. So we are taking an example of Fibonacci series. So let us first understand what is Fibonacci series. So Fibonacci series is a series. Let me write it. Fibonacci series, Fibonacci series is basically a series in which the next Fibonacci series is basically a series in which the next element is the sum of the previous two elements. Okay, so basically we can say in which each number is the sum of the two preceding ones. Okay, so it will start with 0 and the 1, 0 and 1 as a base. We are considering 0 as the first number and 1 as the second number. Then the next number will be 1 again, and the next number will be 1 plus 1 2, and the next number will be 3. Like this it will proceed further. So this is a series and it's a Fibonacci series. Okay, so how we are going to solve it? So basically we can follow two approach. One is recursive approach. So recursion will be involved and completely we will solve using the recursion. And the second approach is we can optimize that recursive code and basically use dynamic programming to solve that. Okay, and we will see how it is working. So let us first start with the recursive approach. So this is a Fibonacci, we can say this is one class we created. Please ignore the spelling. So this is one class created for Fibonacci series. So let us start focusing on the method that needs to be created for calculating the Fibonacci. Okay, so now let us take example of f of 6. Okay, so Fibonacci of 6. So Fibonacci of 6 will be equal to means sixth element, basically Fibonacci sixth Fibonacci number will be like Fibonacci of fifth plus Fibonacci of fourth. Okay, like this. So now let's do one thing. Let's take an integer. So we can take int n equal to something like this. Sixth, we want the sixth Fibonacci number. So sixth Fibonacci number will be 0 1 2 3 4 5 and 6. Sixth will be 8. So our output should be 8. Now we will create a method in which we will pass this integer. So let us create one method. So we can create a method like this Fibonacci and will pass out the n. Okay, so if you will click on this, Eclipse will suggest to create a method, so we can create a method. So we created one public static void Fibonacci of int n, and this is the method we create Eclipse created for us. So as its return type is basically void, we don't want that return type as void, so we can create it in our type whichever we want. So basically we will store it in a long, as Fibonacci is basically calculating numbers, so it can be long. So we will take long as a return type. So let us take long as a return type, and somewhere we can store this in a result. So let us store this in a result long answer like this. Okay, so it will call this. So it's asking for return, so we can add return statement, we can add a return statement. So as of now we are returning in, but the main stuff is what we should return. Let me type it like this. So Fibonacci of n is basically Fibonacci of n minus 1 plus Fibonacci of n minus 2. Now let us run this. Code. So what will happen? Let's see. See, see, it's throwing an exception, and if I'll scroll up, it's basically printing out, and it's is the case of stack overflow. Means it ended up in a infinite recursion, because we don't have any base case, so we need to provide a base case. So as we discussed earlier, base case will be 0 and 1. We are taking from 0 and 1. Okay, so as we are starting from 0 and 1, so we need to have a base case, and then we can return those. So first of all, we will write a base case. So in this method we have to write, if, basically what needs to be done, if n is less than or equal to 1, we need to return, and whatever the n is, we need to return. So in case of 0 it will return 0, in case of 1 it will return 1. Okay, so this is our base case. Now base case is done. Now if I'll run this, it will run without any output, so it's fine. Let's run this first. So without any output, as we printed the long, but we stored the value but didn't printed it. So let us try to print it. System dot out. Okay, so we will use sysout to print the answer. So in this case, it should print 8. So let's see. So it printed 8. Now let us take one big number, something like 55. Okay, 55th Fibonacci number. What will be the result? Let's see how much time it will take to print that. Okay, so see, it's basically taking time. That's where we can say it's a drawback of recursion for using recursion using in these kind of problems. See, it's taking too much time. Let's see when the result will be populated. We can wait for some time. So it's basically calculating, and it got stuck. Let's see. I'm waiting for the results. Okay, let me do one thing. Let me try to terminate this session, and let me again try to run it. It's taking too much time. I don't know why it's taking too much time. We can again terminate this, and let's try with some lower number, something like, let's see, 10. 10. Will it be able? Okay, 1055 is coming. So let's take something like 40. Is it fine? Yeah, let's take. Okay, so it took some few seconds for coming 40. So we can say that recursion will definitely take some time. Now how we can optimize it? So there comes dynamic programming. So now we can use dynamic programming to calculate it. Now first of all, we should understand what is happening and why we use dynamic programming. So whenever we want to calculate, suppose if we want Fibonacci series of 6, okay. Now what is basically Fibonacci of 6? Fibonacci of 6 will be Fibonacci of 5 and Fibonacci of 4. Again Fibonacci of 5 will be Fibonacci of 4 plus Fibonacci of 3, which means definitely, which means we are calculating Fibonacci of 4 twice. Okay, we are calculating Fibonacci of 4 twice, and this computation is taking time. That's why we should avoid recursion in these cases where we are calculating the sub problems again and again. So where there comes the dynamic programming, means we have to basically use memoization to store the results of the already computed results. Okay, so basically we need to store these results, and we can use directly those results to compute it, and that computation time will be reduced. So now let us try to optimize this code. So basically we can use one what we can say, we can use one array to store that. So for that we'll define it here. Let us define it here. and we will call it as a DP array. So static long DP. Okay, something like this, DP. I'll put it as DP, but whenever you are writing any code, make sure that the variable name should be properly named. It should not be like some vague name. So it should be related to what you are doing. Okay, so I named it as DP. So this is basically one array created. So for dynamic programming, we need a DP array. So this is a DP array we created. Now what we can do, we can make it as we can initialize it. So DP array will be DP equal to new. Okay, new long, we should take long, and it should be n plus 1. Why n plus 1? Because obviously if you want the sixth element, suppose if you want the sixth element, so definitely it will be there should be a size of 7, at least 7. Okay, so that's why we are taking it as n plus 1. So we initialize this, and now what we can do is now we need to add the results into this DP array. So what we can do, this is already there. So this is base class, a base case. Okay. Now what we can do, we can store this into the we can create one, suppose long nth Fibonacci number. Okay, Fibonacci. And it will be long nth Fibonacci will be basically whatever the number we calculated, and we will store that into the DP. So DP of n will be basically nth Fibonacci. Okay. So DP of n will be basically this one will be there. Now we need to add one more condition, that is if it is already existed, if DP of n is already there. Okay. So if DP of n which is not equal to 0, we can make it as null also, but as it is long, so we are not supposed to use null, we should use 0. You can research more on this particular thing, why we are not using null and why we are going through this. So let me do it. Sorry, my keyboard is not working properly. Let me do it. Okay. So one thing we can do, if DP of n is not equal to 0, okay, so in this case we can directly return the DP of n. DP of n. Okay. So we can directly return DP of n, and at the end what we need to be return is the nth Fibonacci number. So return nth. Basically what main thing is we are calculating here only, so we will return this. Okay, and we are using the DP of n, so that's also fine. So now I think we are good to go. Let us now take example of 6 again. So it should again print 8. So let us try to run this. So it's coming as 8. Now let's see the 40th Fibonacci series for 40th Fibonacci number. Now that time it took some time. Now let's see if it is taking again that time or it's reduced. Let's do it. See, it came. So that this means that time got reduced. So it directly meant we are not calculating it again and again. We are calculating once and storing the results into the DP array and utilizing that result while calculating the some other Fibonacci number. Okay. So this is how dynamic programming works. So as a homework, you guys can calculate the time complexity when it is a recursive approach, and the next when we are using recursive approach with dynamic programming. Okay. So one thing we can do is like we can print the nth Fibonacci number every time. So we can try that also. So as of now, this is all about the Fibonacci number. In the next dynamic programming series, we will be going to discuss about knapsack problem and matrix chain multiplication, that is medium level problem and high level problem. So we are going to discuss about that. So thank you guys, and please subscribe my channel, and in the next videos we are going to discuss about the knapsack problem. Thank you so much.